Okay, so for our last example, we are actually going to graph it on the calculator. If you don't have a graphing calculator at home that does this, I believe you can graph on Desmos. But for most of the homework assignments, we're going to do it by hand or eliminating the parameter anyway. But I'll just have you follow along on the calculator here. So we've got x equals -2 cosine theta and y equals 5 sine theta. So again, this is a parametric because we've got x equals and y equals. So they're using theta as the independent variable, not t, but it's still a parametric. And they're restricting the theta value or the t value, the independent variable, where we're only going to go from 0 to 2 pi, including 0, not including 2 pi. So when we're typing this in on the calculator, we want to first press the mode button. And you're going to see a screen like this or similar to this, depending on the calculator that you have. But a couple things. We want to make sure we're in radian mode because this is using angles. Right? 0 to 2 pi implies that theta is in radians, so we definitely want to be in radian mode. And we want to move it into parametric mode. All right, so we want to make sure that the parametric is highlighted. The second you switch it to parametric mode, when you hit the y equals button, okay, so when the y equals right under here, you're now going to get a screen that is waiting for an X input and a Y input. So now it's switched it to parametric mode, so that's how we type things in parametric. So we're going to take our two functions, so our one for X, which was -2 cosine theta. Now when you hit the variable button, the X button, it's going to use the independent variable that we use for parametrics, which is t, but the calculator doesn't really know the difference between theta and t. All right, so it's fine that it's going to be t, but you hit that X, t, theta, n button. And then for the Y function, we type in 5 sine t. All right, so then once the calculator has the function, and you also want to make sure none of your plots are on. Okay, so make sure plot 1, plot 2, plot 3, none of those are highlighted. All right, so then before you hit the graph, we want to set up a window. Okay, so window is looking for your independent and dependent variable values. Well, now we have 3. All right, so now we have this new input, which is t. So for tmin and tmax, when you're dealing with theta values, they set it up 0 to 2 pi. So the tmin is 0, the tmax is 2 pi. When you type in 2 pi, it will convert it to a decimal for you. And the t step is every interval that they're going to graph a point in. So I like to use pi over 24. It's a nice fraction of pi over 4, pi over 6, pi over 12, but it's not too small so that it doesn't take a long time to graph it. But this value right here is pi over 24. And then we have to set up our normal window, which is our x-min, x-max, y-min, y-max. So depending on the size of the graph, you can vary this, but having this 2 and this 5, the biggest value y is going to be able to be is 5 or -5. X is going to be 2 or -2, so I just made sure that those values were included. And the scale is just how far apart each tick mark is, so I just usually keep that as 1. Now you can press the graph button, and you should see your graph appear. Let's go back. Which ends up being this vertical ellipse. Now, if you pay attention to the order of the points, it was actually started here and then went in this direction when it graphed. Okay, and the reason why it started over here is because of the negative that was in front of the x. All right. So we started over here in the negative direction and graphed it in this. So if we had arrows, we would put arrows going in this direction, right, to show that that's the direction of the path, all right, of the particle. All right. So again, it's very similar to a unit circle, but it's actually an ellipse because of these different coefficients in front. Right? So now we can see how we could graph different ellipses in parametric mode by just changing these coefficients. Right? And we could change the order of the points depending on the sign in front of both of those. Okay, but this is something that's been very difficult to try to graph in regular function mode. But in parametric mode, it's actually pretty easy. All right? Because x and y are now functions of theta, or what we would call t. Okay, so for your homework assignment, we're going to do this. I'll post this on Classroom, all right, with these notes, and this is going to be due on Wednesday. All right. And for the ones that you're graphing, I want you to try all different techniques. So try doing the point plotting, try doing the eliminating the parameter, and also use the calculator. But I don't want you to use the graphing calculator for all of them. I want you to get used to how we're actually graphing these in parametric